example 2. In the example 2, let me make a x of t, that is going to be number of customers eating food in a restaurant at any time t. Therefore, you are observing the system, you are observing the restaurant, how many customers are taking a food. Therefore, the possible values of the parameter space t is going to be t greater than or equal to 0, and the possible values of s, still it is a count. Therefore, the possible values are going to be countably finite or countably infinite. Therefore, this collection of a stochastic, this collection of a random variable over the t, that is going to be a continuous time or continuous parameter discrete state stochastic process. This is a very typical example. So, it could be a countably, this S could be a countably finite or countably infinite also. Now, let us see the third type, that is a discrete time continuous state stochastic process. That means we need the possible values of a capital T has to be a countably finite or countably infinite, whereas the possible values of the state space has to be uncountably many of that type. So, let us create an example for that. The x suffix n, that is nothing but it is a random variable that denotes the content of a dam or water reservoir observed at nth time unit. So, here the time unit could be every 1 hour, or that could be a, because you are seeing the what is the content of the dam or water reservoir, it could be every day at a fixed time of every day, or it could be a fixed time of weekly once. So, that is going to be the time unit. So, at the end of each nth time unit, you are observing what is the content of dam. So, that is nothing but it is a real quantity. Therefore, the capital T is going to be, you are observing at only at the time unit. So, either it could be either 1 hour or daily once or weekly once and so on. Therefore, I can make a one-to-one correspondence with the countably finite or countably infinite numbers. So, that will form a parameter space, and the capital S, this is going to be the possible values of x n for all possible values of n. Therefore, this is the content of the water content of a dam, that is going to be the real quantity. Therefore, that is going to be a sum x, where x is always greater than or equal to 0. So, that means you have the parameter space is going to be a discrete, whereas the state space is going to be a continuous. Therefore, this stochastic process x suffix n for possible values of n is going to be 1, 2, 3 and so on, and this is going to form a discrete time continuous state stochastic process. Let me give one more example for the same type, that is example 2. That is nothing but example 2. X n is nothing but the amount of $1 in rupees at nth time unit in a day. That means I am just observing what is the value of a 1 US dollar in rupees in a day for the nth time unit. It could be every 5 minutes, or it could be every minute, or it could be every hour of any particular day, and that is going to form a random variable, and that collection is going to form a stochastic process. In this, the possible values of x is going to be, since it is the amount of 1 US dollar in rupees, it could be some fraction also. Therefore, you do not want to take it as the integer number, it can be a real numbers. Therefore, it is going to be a possible values of x greater than or equal to 0, and the capital T, that is going to be the time unit, either it is every minute or every once in 5 minutes or once in 10 minutes or every 1 hour and so on. Therefore, this is going to form a countably finite or countably infinite one, and this stochastic process will form a discrete time and a continuous state stochastic process. Let me go for the fourth type, that is the fourth classification of a stochastic process, that is a continuous time, continuous state stochastic process. That means the possible values of a parameter is going to be a uncountably many. Therefore, you get the continuous time or continuous parameter, and the possible values of a state space, that is going to be uncountably many. Therefore, you get the continuous state, the stochastic process. The examples are, the first one, xt is going to be temperature of a particular city at any time t. So, whenever I use any time t, it can take any value. Therefore, the possible values of S is going to be, it is going to be the temperature. So, you can think of the temperature, suppose some particular cities lies between -50 to 60 degree Celsius. So, this quantity S is going to be the Celsius of -50 to positive 60, and the parameter space T is going to be, you are observing over the time. Therefore, this time is going to be greater than or equal to 0. Therefore, the parameter space is a continuous one and the state space is a continuous one. Therefore, this collection of random variable, will form continuous time, continuous state stochastic process. Let me give one more example of the same type, the fourth type, that is example 2. X of t is going to be the content of a dam observed at any time t. So, the content of a dam or reservoir, that is going to be the real quantity. Therefore, S is going to be a collection of x such that x is going to be greater than or equal to 0, and you are observing over the time. Therefore, that is also collection of t such that t is going to be greater than or equal to 0. Therefore, this will form a stochastic process in which it is going to be the classification, it will be under the classification of a continuous time, continuous state stochastic process, and this can be created with the help of the first approach. That means, for fixed t, you find out what is the random variable and you collect the random variable over the all possible values of t. Therefore, this is going to be of the continuous time and the continuous state stochastic process. So, in this lecture, what we have seen, what is the meaning of a stochastic process or how to create the stochastic process. So that is nothing but it is going to be a collection of random variable. So we have defined the stochastic process as well as how to create. Then later we have given what is a parameter space and what is a state space, and we have given the classification of a stochastic process based on the parameter space and the state space. And also some of the real world problems, from that we can create a stochastic process, and that stochastic process or the simple stochastic process, and there are many more stochastic process can be created with the help of the definition and so on.